Now that you've achieved superior mastery at reading your flight instruments, let's learn what makes them work. We'll start with the instruments that measure air pressure. These are the ones that use the pitot-static system. They are the airspeed indicator, or ASI, the vertical speed indicator, or VSI, sometimes known as the rate of climb indicator, and the altimeter. As a review, I'm sure you remember pre-flighting the static vent on the left side of the fuselage. Well, all three of these instruments, the altimeter, the vertical speed indicator, and the airspeed indicator, are connected to the static vent in the calm air outside the aircraft. Contrary to what it sounds like, the static vent isn't where the static from the radio drains out. It doesn't work that way. There is no such thing. The static system vent is basically a hole to the outside of the airplane that is connected by plastic tubing to each of these instruments as shown here. The hole for the static vent needs to be placed so that it is not affected by the slipstream and ram air pressure. This allows it to get a good sample of the natural weight of the atmosphere. Okay, let's follow the static tubing to the altimeter. Notice that it is the only input to the altimeter. And as you remember, the altimeter simply measures atmospheric pressure, and it does it just like a barometer. The key part of a barometer or an altimeter is a sealed, flexible capsule that expands or contracts with changing atmospheric pressure. Think of it as being like a sealed bag of chips that expands as you gain altitude, except that it doesn't explode if you get too high. The changing shape of the capsule is mechanically converted into an altitude reading on the altimeter's hands. And the altimeter's hands tell you your altitude in thousands of feet above sea level. The lower the pressure, the more the capsule expands, and the higher the altitude indication. This works by comparing static pressure found outside your airplane with the pressure value that you physically set in the altimeter's window. And this value is known as the altimeter setting. We can obtain the altimeter setting from air traffic control via radio. The altimeter setting is essentially the surface pressure at the reporting ATC facility corrected to sea level. When you set that number in the altimeter's window, then the altimeter's hands read your altitude above sea level. Now, suppose you're departing an airport and the altimeter setting is not available. Well, you don't have to be the sharpest knife in the drawer to figure this one out. If placing the altimeter setting in the window makes the altimeter's hands read height above sea level, and if the altimeter setting isn't available, then bypass the middleman. Before you take off, rotate the altimeter's knob until the hands indicate field elevation. Now folks, flight instruments are really pretty exciting. In fact, I wish I could be out there learning this stuff with you. So let's follow the static system over to the vertical speed indicator. And as you can see, it only has one input, and that's for static air pressure. The vertical speed indicator is really kind of interesting. It's basically a container with a capsule with a hole in it. As you go to higher altitudes where the air pressure is less, the air wants to rush out of that hole through the static system vent. As you go to lower altitudes, air pressure wants to rush in. The vertical speed indicator simply measures the speed at which the air rushes in and out of that vent hole and translates that into your rate of climb or descent. Finally, we come to the airspeed indicator, which is also connected to the static system vent. But in addition to being connected to the static system vent, the airspeed indicator is also connected to the pitot tube from which we obtain ram air pressure. You remember that the pitot tube is located on the leading edge of the wing. Here is the opening where it samples ram air pressure. As air rams into the pitot tube, it increases the pressure inside the tube. Make the airplane fly faster, and you further increase this ram air pressure. And the ram air pressure sensed by the pitot tube goes directly into the airspeed indicator. Now, the key part of the airspeed indicator is a diaphragm that has ram air pressure from the pitot tube on one side and static air pressure from the static vent on the other. Basically, the airspeed indicator measures the difference between ram air and static air pressures. And because the airspeed needle is connected to the diaphragm, the difference between these two pressures is converted to an airspeed needle movement. The greater the difference, the higher the airspeed reading. Well, folks, if you're like me, and I know I am, then you like learning about flight instruments. So now you know three instruments in your airplane that work off air pressure. They are the altimeter, the VSI, and the airspeed indicator.